Welcome everyone. Hopefully you can hear me and see me. My name is Norbert. I'm the organizer of this lovely meetup group, and I will start up the event with a small presentation from my side. So first I will have to share my screen. Okay. Now, hopefully you see my screen. So welcome to this year's last BudapestJS meetup. I guess you are already familiar with the agenda, but I will also introduce our speakers as we move on. But first and foremost, I would like to start with a round of applause and thanks to our sponsors. So BlackRock and Contentful, thanks to them, we have Balazs and Stefan as speakers for this evening. Hopefully they will also introduce BlackRock and Contentful for a bit. Thanks to Prisma, we have actually this, among many things, but this evening we have this streaming setup configured. So right now we are streamed to YouTube, but this will also handle the recording and transcribing of the talks. So we get to send it out later on. And thanks to JetBrains, we also have some things to raffle. So a license coupon, which we can send to you that you can use to redeem top-notch tooling for JavaScript development and everything else if you're familiar with their product suite. So last but not least, BudapestJS is a completely community-driven event. So it's free time. We don't have a specific organization backing us. So there's always ways you can help out. We're always in need of speakers. If you have ideas just about topics that you would like to hear about, we also welcome those. Feedback in general is appreciated, and just spreading the word. So get the word out. We are always keen on reaching a bigger audience, especially for our presenters, as they do a lot of prep work for these events. And that would be it from my side. I would like to hand over the stage now to Daniel, who will introduce Prisma a bit. Yeah, some of you might be familiar with Daniel. He already did a talk for us, I think 3 months ago, right, about Prisma. And among many things, he already convinced me to start using Prisma. So Daniel, the stage is yours.
Great. So hi, I'm Daniel. I'm going to just add my screen to the stream. So hi, my name's Daniel. I'm a developer advocate at Prisma, and I'll try to keep this as brief. If you're interested in getting more information, I'm sure I'll share some more links about that. So Prisma, what is it? Well, Prisma is an ORM that makes working with databases easy. And one moment, I'll just make this full screen. And yes, so Prisma is an ORM that makes working with relational database easy in Node.js, and you can use it with TypeScript. And this is a common problem in the Node.js ecosystem. If you've worked with a relational database like MySQL, Postgres, or one of the many others that exist out there, there's it's quite challenging working with these types of databases. And at Prisma, we're tackling this problem by allowing you to sort of interact with the database by having these two core benefits. The first one is higher productivity with things like rich auto-completion and code generation. And the second is increased confidence with type safety. So Prisma consists of 3 tools. Prisma Client is the ORM. That is what you use in your application to access the database. Prisma Migrate is the tool that you use in order to migrate your database schema. And finally, Prisma Studio is a modern and intuitive database GUI. So let's look at what a query might look like. So here in this little handler that I have here, this might be a REST API. You can see that I'm actually creating a user in the database. And you can see that what we're getting here is we're getting a lot of these type errors based on the schema of the database and what we're actually fetching from the query. So this is just to give you a little glimpse into what you can do. And you can use Prisma with any framework, really. We have a lot of content on each one of these frameworks. So Next.js, which is a React-based Jamstack-like framework. You can build GraphQL APIs. You can integrate this with Apollo to also build GraphQL APIs. You can use this with Nest.js, Express, or Happy. And for all of these, we have examples on the Prisma examples repo, for which I will drop the link in the comments. So that was it from my side. Feel free to reach out anytime, and I will drop the links. Now, if you would like, we have a lot of stickers. And if you're interested in getting some of those stickers, you can go to some of those pages for which I'll drop the links, and you can get your stickers here by ordering them. So that's it from my side. Thank you for watching this, and try it out when you have a chance.
Thanks, Daniel. And it was a quick and good introduction of Prisma for those who are not yet familiar with it. And now on to our main speakers of the evening. So our next speaker is Stefan. As most likely some of you are already familiar with him, as he was already kind enough to do a couple of talks for us, both online and offline. So he was already in Budapest and for one of our meetups. I always love to have Stefan as a speaker because he brings a unique and critical view of web development amongst many things. And his talks always have a main takeaway and real-world experience and usage that you can leverage starting from tomorrow. So Stefan, again, thank you for doing this, and the stage is yours.
Thank you very much, man. I'm almost blushing here and now. All right, let me just hit play here on my little thing. And I don't see the streaming software anymore, but does everybody see write a function here right now? I assume everybody does. Okay. No feedback. Okay, let me just see. Yeah, that looks good. All right. Hey, thanks so much for the lovely introduction, and thanks so much for having me again. Let's talk about serverless and functions, shall we? And I really consider functions, as we're using them today, as glue-driven development for front-end engineers. So let me just quickly introduce me a little bit more. So I'm Stefan. I'm building stuff for the web now for almost a decade, and I work for a company that is called Contentful. So in case you're wondering how you can bring in a API first or a headless CMS into your Next.js apps or your Happy apps or your Express apps or whatever you're building, and you don't want to set up your own database and deal with a content management system, actually, you can give Contentful a try. But the main thing is that I'm really just a front-end developer, and I just love it. I really care about building beautiful UIs and websites. And over the years, I figured out that a very nice UI can really spark a lot of joy in myself. And while I do build things for the web, there are a set of things that I don't care about that much. So for example, even though we had Prisma just giving a little intro, and Prisma is a great service, usually I don't want to deal with setting up servers or databases. And I just want to build front-end things for the web. And I also don't want to write or set up low-level deployment scripts. In the past, I worked for companies where we had massive shell or Ruby scripts that were just rsyncing files or SSHing files to a remote server. And I really don't want to deal with that, because the only thing that I really care about is beautiful UIs and websites. And when I started building for the web, there was a very strong separation of developers. So I did my first job and was an internship at an e-commerce shop here in Berlin, and it was a PHP Magento shop, and we had some little bit of jQuery in the front end. And there was a clear separation of the developers working on the back end and on the front end. This then changed over the years, and the main reason for that was that Node.js appeared, right? Node.js was then the first steps of JavaScript and front-end engineers entering the server side. So from one year to the other, we were able to write our own tooling, to write our own deploy scripts, and maybe even to run our own web servers. And when I figured that out, I was overly excited about deploying Node.js servers everywhere. But this comes with its own set of problems, because how do you set up and scale the Node.js servers? So when you do Node, you might know that Node.js processes just die. So you have to figure out what to do then. And how to do you parallelize maybe different services running in Node.js? And I came to the same conclusion that I don't want to deal with that. So what I did then is that what I tried is I gave Heroku a try. So in case you don't know Heroku is one of these platform as a service providers. They deploy your stuff, they scale it to a certain extent, and it more or less works out of the box. So I built this little thing here. So what you see is perf tooling today. I like to make lists of things. So what you see here is perf tooling today. Unfortunately, I'm not maintaining it anymore, but this runs still on Heroku. I'm still paying $50 a month because it's sitting there. And now the web development industry progressed a little bit though. What we have now is that we have providers like Heroku, but we also have new and fancy providers like Netlify, for example, or Vercel. And there are several more services out there. And depending on how you define this whole term of serverless, everything changes with it. And before we move forward, I want to just bring a brief introduction of what actually serverless means to different people. Depending on who you talk to, serverless could mean just that there are a bunch of API providers that run in the cloud, that provide their servers and you an API so that you can just use things. Serverless could also mean function as a service, which I'm going to talk a little bit about today, which is mainly Google Cloud, Azure, and AWS Lambda. And the idea here is that you publish or push a little bit of source code, and this is then run by the infrastructure. Or just because developers like to troll each other, serverless could also mean the serverless framework, which is a framework to orchestrate serverless functions. And now in 2020, serverless really became kind of a thing. And I think that development practices become a thing when Martin Fowler decides to write about it. So Martin Fowler is an expert in software architecture. So when this article appeared on his blog, I decided, okay, serverless is the thing. So now we have these three definitions of serverless. And I think, well, maybe serverless is more like an idea. Because when you think about the whole fact, and I worked in companies where we had engineering teams and we maybe even set up our own servers sitting in a data warehouse. When you think about the fact that usually when you use a cloud service, it is almost always cheaper than doing it yourself. Even when you consider a $50, $100, $200 subscription for a cloud service or a serverless service, this is usually still way cheaper than paying a single engineer. So for me, serverless is more like an idea rather than a single implementation. And when you do front end, this is what you're doing anyways, right? So when I'm building a website or when you're building a website, usually you have an analytics solution in there because most of the people don't want to build their own analytics service. Maybe using a cloud CMS like Contentful, maybe using a cloud storage like Firebase. Maybe you're using your error monitoring with Sentry, self-hosted or in the cloud. Or you're using something like Algolia, which provides you a nice and easy solution for cloud search. A little side story about Algolia. I worked once at a company where we tried sprint over sprint over sprint to make our search experience faster. And even after several iterations, we still didn't make it to be as fast as Algolia is, because they're specializing on this one single thing. And today you really don't have to build everything yourself. And there's this really nice resource from the people of CSS Tricks. So, and basically this is a collection of things that you can use when you don't want to reinvent the wheel. And serverless.csstricks.com covers things like for serverless functions, for authentication, for forms, for notification, hosting. Most likely for everything, there's something that you can use out of the box. And for me as a JavaScript developer, this really just boils down to the fact that everything becomes Legos, because I can just connect all the pieces with a set of APIs. And especially in the Jamstack world, serverless gains more and more attention. So let's just talk briefly about the Jamstack. So this is the first definition of the Jamstack. Initially, when the people came up with the Jamstack idea, this meant JavaScript, mainly in the client. It meant the usage of APIs, and it meant pre-rendered markup. And I love that. I think this is a great architecture for front-end developers. But when you think about this definition of JavaScript APIs and markup, people figured out this year that this is maybe not the right approach. So the Jamstack became the Jamstack without 3 capitals, because not everything needs to be JavaScript driven these days. So when you go to jamstack.org, you will find out that the claim of this architecture is that it's the modern way to build websites and apps that deliver better performance. And there are two core principles of this architecture. So the one is that it still delivers, or it delivers statically pre-rendered HTML, and then it bets on decoupling. That then enables greater confidence and more resilience. So how do you usually build a Jamstack site in 2020? So first, you have to figure out what technology or framework you use. You can also roll your own if that's what you like to do. And there's a variety of things out there, going from Next to Nux to Gatsby. I'm recently more like an 11T fanboy. And then you have somewhere a build server that uses the framework and fetches a lot of third-party data. So what you see there, for example, are the data providers that power my own private website. So you see there that I have Airtail, Contentful, Button Down, which is a newsletter provider, Feedly, which is my RSS reader, but I put that on my website too, and a little bit of GitHub stats. And the beauty of the Jamstack then is that the result is static HTML, which means that you can put it on a CDN. This is fast, secure, and scalable. And then when something updates, you have 2 options here. So basically what you can do is you can go into your provider or into your setup and you press a button to rebuild the website, or you connect then all these third parties that you can use with an automated webhook, so that whenever something changes in the data storage or service that you use, that the website gets rebuilt. And with an architecture like this, you can really outsource most of the things that you are implementing over and over and over again. This can range from authentication to payments to content management, data search, and much, much more. And when I started building for the Jamstack and playing around with it, I think this idea is great, but I had the problem that you really cannot use every API in the front end. So let's just have a look at the example of sending emails. So you might want to choose that you use a provider like SendGrid, which is an email provider. And you could potentially install the SendGrid SDK and then send emails right from the browser. But what happens then? Then this guy, the hoodie hacker, appears, and the hoodie hacker will find your credentials because you're exposing them in the client. You don't want to have sensitive clients and tokens in the browser because people can just snoop around. And this is where this missing piece came into the play for the last few years, which is serverless functions. So let me just show you one serverless function example here. So this is what it takes. It is a typical JavaScript function because I like to write JavaScript. And you see here that it is exporting an async function and saying hello from Lambda. When you extend this example with just a little bit and you return an object and the status code, you will find out that, congratulations, this is already an HTTP endpoint that front-end developers can use and deploy. Serverless functions do not only support JavaScript, though. The support ranges from C# to Go to Node to Python, Java. So whatever rocks your boat, you can use that. And this then has the benefit that you don't have to worry about that. You can push that code and it will run and it will work. These kind of functions, when you're using them for HTTP, for example, are automatically upscaling. So when you have a Hacker News hit or you run some big promotions, you can bet on the serverless functions because your provider will take care of scaling that up. And the beauty of this is that you're not paying for these when they're not running. And then you have these little tiny pieces and decoupled units that do one thing only, and they do it well. So what's the overall cost of serverless functions these days? When you go to Netlify, you get 125,000 serverless function invocations per month. When you want to go a little bit more low level and you want to take the journey into the AWS admin interface, you get 1 million free requests per month. So how could we tackle now our problem? So this is already an HTTP endpoint that we could use like that in our Jamstack sites. All we have to do now is to bring in some functionality to send an email. And what we can do is that we can parse a request body. When you just make a post to this endpoint, you will know the URL depending on what infrastructure you choose. And then we can define another function, which is send email. And then you use the third-party provider of your choosing. And to see here already that this is the core part of being the glue for front-end developers, because you can now hide sensible tokens in the environment itself, which means that no hoodie hacker in the world can figure out how to send emails in my name. And then you can send the email. With this approach, hoodie hackers won't find your credentials, and you as a front-end developer really can just connect all the pieces, which I think is beautiful, because now you can leverage all these great free services to play around with. So what am I doing with serverless these days? So I really dabble around with my website, probably way too often. But when you go to the articles, you see that there's an old school view counter or a stat counter. And this is actually powered by an Airtable spreadsheet. So Airtable is this spreadsheet as an API service. If you haven't checked it out, I think it's beautiful. If you ever tried to kind of automate Google Sheets and found out how terrible this is, so Airtable is a nice alternative there. And it's just being powered by a serverless function on Netlify. So whenever someone visits this article page, I'm just increasing an integer somewhere in the spreadsheet, and I'm giving back a new number. Or another example is that I have this little form down here, which subscribes people to this newsletter service that is called Button Down. So when you're, for example, using Netlify, you can define so Netlify has a little bit of form magic if you want to use that one. So you can define an action, which is then the result of a redirect. And then you can just upload a submission created function, and Netlify will connect the pieces. So it will give you the data, what was included in this form submission. So that even when people don't have JavaScript enabled or it fails for a reason, that still works. And with 24 lines of JavaScript, I can now connect another API provider. And in case you're wondering, or in case you're interested in these slides, they are available under my-links online. And I have to tell that really everybody, because I feel like the troll on the internet, because I own the domain my-links online. So when you want to have the slides, they are under / write a function. And guess what? That's a serverless function too. So what I do here is that I'm using Contentful to power the content on my website, and I have a little bit of configuration to add new redirects. So whenever something hits this AWS Lambda function, I'm fetching the content and I'm redirecting there. This is 32 lines of JavaScript, and I just built my own bit.ly, right, to handle redirects. If I would like to count how many times people follow a certain redirect, I could also just connect that to a spreadsheet. So these are the use cases that I have for serverless functions. But I also thought that it might be cool to find out what other front-end developers do with functions these days. And a few people replied and said, well, for example, the people from JavaScript Conf Hawaii, they do something like SMS-based code of conduct reporting. And now think about this, front-end engineers sending SMS. I think this is beautiful. Or our friends from Leads.js, they also put it to the next stage where they schedule tweets, they schedule emails, they pipe around Slack posts, and they create tickets in one platform and another. And at the end, it is connecting all the APIs together because we now have the infrastructure to do so. And last year, I built something that I think is worth sharing, which is this. So for example, what you see here is Grandma's Gallery. And it's basically a website that my grandma can open on her tablet. And when my grandma presses this button, all her grandchildren receive a WhatsApp message. So how does that actually work? So the way that this works is that this is another site that runs on Netlify. And whenever you press this button, a serverless function is executed. This then goes to Twilio, and Twilio will send a WhatsApp message to pre-configured WhatsApp numbers. So when now one of the grandchildren, maybe it's me, answers this WhatsApp message, Twilio will send a webhook to rebuild the whole website, so that my grandma always have a nice little thing sitting on her table, and every now and then there's just a new image appearing from the grandchildren. And the list of use cases is really just going on and on and on and on. So for example, I was on the stream with Jason Langsdorff, and we used a serverless function to gate content on a website. So what he built is that he integrated Stripe with some serverless functions. And then when someone wanted to access some content, we piped everything through a serverless function to then figure out if this person is allowed to access some content. And if they were, then we just returned the content. And I think this is just honestly freaking cool that we now in 2020 can do all these cool things. If you want to learn more about these things, what I can highly recommend is this talk by Chris Coyier, and it is called The All-Powerful Front-End Developer. And basically what he does there is he's doing the whole round of third-party services with generous free tiers that you can use to build very quick products and sites. I feel like that it has never been easier to build products and sites that quickly with that many options, because we can now rely on services that focus on one thing and do it well. Serverless functions at the end of the day, for me, were the missing glue to front-end awesomeness, because now we have this big bucket of options, and the only thing that we have to do is connect all the pieces, because we can control a little bit of infrastructure too. Just as a side note, something that I am very excited about is another serverless function provider. And if you haven't had a chance to look at it, I can recommend to check it out. So Cloudflare just recently also joined the serverless functions game. And what they do is that they have something that they call Cloudflare workers. And while all the other providers have this common module exports or Node.js kind of syntax, Cloudflare goes a little bit into a different direction. So Cloudflare is modeling their serverless functions based on the service worker API. And this feels a little bit uncommon when you think about this, but this opens up for completely new use cases. Last year I was giving this, I built this prototype, and what I did was that I had a React app and I rendered it server-side in a service worker, and I rendered it also server-side in a Cloudflare worker. So what that means is that I had the same code base running in 3 places, in the client, in the service worker, and in a Cloudflare worker. And this is just so nicely nerdy that I would like to continue exploring this approach. But it's not everything super great about so there are obviously also downsides when you want to decide to go for a serverless architecture. So first of all, when you go down the way and you want to use serverless functions all the way down, testing and debugging serverless functions can be a little bit tricky. When I started doing serverless functions, it was actually fairly tricky to develop these, because you had to do a git push and you then had to figure out if it's working or not, and the workflow wasn't great. But over the years, this became a little bit better. So Netlify and Vercel, which are both my tools of choice, and I'm just changing like how the weather is and depending of that. So they both offer now a CLI that is kind of mimicking the production environment that they have. So you can now develop serverless functions right on your machine, which gives you a really nice development experience. The logging is still a little bit tricky though, because you still have to figure that out, where to fish out the logs in the cloud. Then you always have to remember that serverless functions are not ideal for long-running tasks. So if you want to crunch some image data, do some heavy data manipulation, or do anything that takes a little longer, you have to be very careful, because the providers out there also provide for execution time or bill on execution time. Some providers out there also suffer of cold starts. So the way that it works is that we have a little bit of code running in the cloud, and it is not running when you're not calling it. So sometimes it can take a second or 2 or 5 until your HTTP endpoint answers your requests. So you have to be aware of that, depending on how performance critical that is. There are also some hacky workarounds. And probably the thing that you have to get used to the most is that you don't have state. A serverless function is an encapsulated single piece of thing that runs in the cloud. You cannot just write something to disk and read it out later. So you have to find a way to connect and share state across these. But as always in development, it's really it really depends on what you're building. And for setting up and building up a project very quickly, I think that serverless functions are a beautiful thing that we have these days. And it's excellent to know some JavaScript. I mean, we're coming from the way where we maybe did a slide down and slide up because we know a little bit of JavaScript. And now we can build beautiful products and websites on the one hand, but on the other hand, we connect and use all these APIs that are out there to complete and really finish the thing. With a little bit of JavaScript these days, you can come very, very far. And maybe my friend Marcos takes it to the next level. You can also be very dangerous because we have a lot of power with the infrastructures that we have these days. So for me, I think I use functions really for the majority of things that I do, because I do rely on a lot of third parties. And over the last 2 years, everything really became just Legos for me. And that was my little intro to serverless functions. I'm Stefan. Thank you very much for listening.
Thank you, Stefan, for the awesome talk as always. That grandma gallery application is really a killer one. That really solves a specific problem. That's really awesome. Guys, you can ask questions from Stefan in the chat, in what we have in YouTube. So feel free to note down or just give him a thumbs up. I would like to kick off with a question. It might be difficult to answer right now. Just that my observation in the past is that for technologies that become, I would say, more of a mainstream tool, they usually have a killer app. Like classic example is for Ruby, it's Rails, like 10 years ago or so. Do you think there's a killer app already for serverless, or that's still waiting to happen?
I think a few years ago, the killer app, at least how I started doing serverless, was actually really the serverless framework, because it was this first way to orchestrate, and AWS was the first thing that I played around with. That was pre-Netlify and all these newer hosters. And if anyone ever entered the AWS admin interface, it's not that straightforward, right? So at that time, the serverless framework was for me just really, let's define some YAML files and everything will just work automatically. I think that over the time now, over the last year or two, this changed to that there is no killer app anymore, because when you think about the use cases, at least what all the front-end developers do is they use it for a very single purpose thing. And the tool chains that we have these days are fairly nice. So when you use, and I'm a little bit of a Vercel Netlify fanboy here, right? But they do the heavy lifting for you. And it really boils down to writing 20, maybe 50 lines of JavaScript. And then it just works. So, and I think we see a shift in hosting providers over the last year, because these new providers, the developer experience these days is just so nice. Honestly, sometimes when I do a branch deploy and it's automatically on a different URL, and then I just have to merge it and the functions are all set up and everything is just cool. So maybe the killer app is just the new hosting providers that we have, because I think like for front-end developers, it's just beautiful time to live in.
Yeah, I also use Netlify and I was surprised how much it provides out of the box. And yes, we are not affiliated with Netlify, but it just works. Okay. Meanwhile, you can still write down the questions. I'm going to note 2 things. If no other questions, I will have one more for you, Stefan. So you might have noticed that magic happens behind the scenes. So when I say the word that, let's say, Stefan has the stage, then it happens. Well, that's thanks to Natalia from Prisma. So Natalia, thank you for helping us out here. We really appreciate it. It's wonderful. The second thing is, in the event I mentioned that there will be a raffle, and even in the beginning the JetBrains sponsors the event. This means that I have 2 license number, or actually those are coupon codes that you can apply to any JetBrains product and get it for free. So I will send out a form link in the message box on YouTube. You have to sign up for that, so I need an email name, which I can later on use to find the winner. I'm now feeling a bit ashamed because I'm not using serverless functions to get a winner from the list of entries, but now you gave me, yeah, exactly, you gave me some homework. I will just share my screen and use Google Sheets to find something randomly. And this leads me to the same point that you mentioned, Stefan, with Airtable. I tried to automate it in Google Sheets and
it's such a hassle. Oh
exactly.
My God.
Exactly. So I was like, oh, fuck this shit, I'll do it by hand.
That's what you said, but I thought that, yeah.
Yeah, so, okay. One last question about their topic. So far, I gathered that serverless functions are mostly used in applications that are public-facing. Would you also consider it for internal applications? I know, like, large companies have their own software solutions. Would you consider, even they are building single-page applications, so they're JavaScript heavy nowadays, but is it a solution for potential or a backend solution, kind of, at least to a degree, in those private-facing applications as well?
I mean, it depends kind of what you're doing. Even though when you're doing private applications, you still probably have something like an auth layer in there, right? Something to see if the people have the right access. You would have to bring that in then there too, and probably rely on some kind of session there. But you can totally do that too. If it's not too Yeah, no, I'm stopping there because otherwise I'm probably not giving it too good recommendation here.
Okay, I mean it's a potential start, but yeah, I mean that's you have to give it a shot. That's the beauty of it.
Yeah,
exactly. But it's really easy to get started. I do agree with that. Okay, let me see whether meanwhile we had some other questions popping up. As far as I can see, no. So still, if you have something pops in your mind, feel free to write it down. Again, Stefan, thank you very much for doing
Thanks for having me.
As always, I hope to see you next time as well.
I'm sure we will
hopefully
see
it hopefully in person. Yes, yeah. Yes. Okay, so our next speaker for the evening is Balazs. Now, Balazs is a huge contributor to, among many things, but I will name BudapestJS. Currently, he leads the number of presentations and talks. So he's kind of the pole position holder. I lost track of the number of presentations he did. Why I really love having Balazs as a presenter, and I think it's always a boon for the audience as well, is because he's the guy who's seen things. So he's not just a web developer or just a backend developer. He's really a full stack software engineer, and he always thinks like a software engineer in large scale settings. So there's a lot of things you can learn from him and a lot of wisdom, which is coupled with humbleness. So Balazs, thank you again for doing this talk, and the stage is yours.
Thank you. So very see kids running normal around and I share my screen.
Balazs, you might have to mute the YouTube. I mean, turn off the sound on the YouTube sharing. There seems to be a bit of an echo coming from it.
don't have YouTube or YTV. Check this out.
It's the sound is pretty terrible. I'm not sure what goes on. There seems to be like an echo delay kind of thing, or it might be a bad internet connection.
Just a sec. Technical issue.
What we can do, if you don't have YouTube open and running with sound, if you do, please close that. And what we can try is if you disable your camera, whether the voice or sound improves or not. Meanwhile, guys, while we are sorting out this small technical difficulty, I'm going to give you a link which you can use to sign up for the prize we have. And here we go. I'm going to put this on YouTube. And there you go. You can sign up there. So Balazs, is it better now?
Not at all.
It doesn't seem to work. Okay, meanwhile, we are sorting this out. Yeah, most likely internet connection, we'll have to see.
Can you hear me?
The sound is still pretty terrible. Okay, so sorry guys for the technical difficulties. Sometimes this happens even in in-person events. Meanwhile, here's your chance to sign up on the referral form. I'm not going to give you tips on how you can cheat, but I guess you figure it out, but I trust that you are fair. And remember, we have 2 licenses, so there will be 2 winners for the evening. Also, Daniel mentioned about the Prisma stickers. You can take the time to sign up for those as well. Last but not least, we also have BudapestJS stickers and magnets. I think you can see it now. So this is a magnet which I can stick on my desktop. If you want one of those, usually we hand those out in in-person events, but you can write to contact@BudapestJS and we see how to sort it out. I'll send the email to the chat. Let's see whether Balazs' connection is better now.
Hello, can you hear me?
Awesome, now it's awesome. We see you, hear you, it's perfect, Balazs.
Let's see whether it's going to be awesome or not. Okay, so after sorting out some technical difficulties, hello everybody. So I'm Balazs, Korossy-Khayll, and I work for a company called BlackRock. And so Norbert asked for a little bit of an introduction. I don't want to go into much details, but BlackRock is the largest asset management firm. And what that means is that you probably have some kind of a retirement savings plan, whether you have some private ones, or maybe your company is paying for you, or maybe you just have the state one. But if you have a private pension plan, for example, there's a good chance that you're investing in some kind of a product that was created by BlackRock. And so BlackRock is not just a financial asset management company, but BlackRock is also selling the software that we ourselves are using for managing assets. So BlackRock is selling the software to other companies as well. So you can say that BlackRock is a financial company, but also a tech company as well. Okay, so, and I am actually leading a small team there at BlackRock. And so first of all, I kind of want to explain why I'm thinking about micro-frontends. Because this talk is going to be about micro-frontends, and first I'm going to show some slides, and then I plan to show you some code that hopefully will help you understand and create micro-frontends. So let's look at this happy developer, right? So why is somebody a happy developer? So there's a number of different like theories about this. For example, you might say that you need to have autonomy, mastery, and purpose. That's a popular view, right? Right now, I just want to focus on what makes somebody a happy developer when you look at the code, right? So a happy developer, in my mind, deals with a unit of code, like one unit of code that fits into the head of this happy developer. So if I need to work with a code base that I can understand and that I can instantly think about the different parts of it, then I'm fine. If I need to work with a code base, however, that is large, and I don't even know where I begin to search for something, then I'm becoming unhappy. Because there is a certain amount of knowledge or a certain amount of things that fit into my kind of working memory, and I'm happy if the code base is something that can fit into my working memory. So this thing happens with a team as well, right? So an unhappy team needs to deal with a large amount of code. And there might be some code base from one application, there might be some code base from another application, or it might just be the same application. It's a large, complex application, and that application might have parts that you don't deal with anymore because they are fine the way they are, they work. Or maybe some part of the code was done a long time ago by some different developers that are no longer in the team, and so on. So the code base can be very large. And some of the code, as I mentioned, can be considered legacy code. So I think if you haven't touched some parts of the code for a year, you can consider that legacy code, and you don't even know how it works. Maybe 6 months ago, you still remember something, but what you really like to work with is what you're currently focusing on. And so if there is all kinds of other code that you're not currently focusing on, then you're not a happy developer. So the question is, well, yeah, can the team be larger? Because, yeah, more people can deal with more code, right? So that doesn't really work because of a number of things. So the communication overhead is one of the major contributors, and especially if the team is spread out over multiple locations, right? The locations need to synchronize. Maybe they're in a different time zone, but even if they're just physically in a different location, it's going to be a problem to discuss things, to come up with solutions for problems. And so what happens is that you start to introduce standards and conventions, and these things tend to slow down the development, right? Because you need to synchronize with all the team, and if there's a lot of code, then these things kind of are needed for the code to be a consistent, good quality code. So what else can we do rather than increasing the size of the team? So what I've been describing is kind of a monolithic front end, right? The monolithic front end is just one application that has a lot of different parts. It's a complex application, and all projects start like this. You could say that on the left we have the front end, in the middle we have the back end, and on the right we have the database. So the applications grow and grow and grow, and this is where you have a lot of complex stuff happening in your application. So on the front end, let's focus on the front end. On the front end, you could have a number of different problems when you have a large application. It's one package JSON. So that one package JSON creates a problem, because if you need to, for example, update your framework, whatever front-end framework you're using, you need to upgrade from one version to the other. There might be libraries that are not compatible with the newer version of the framework. So the more libraries you have in your large application, the more it can happen that you cannot easily upgrade to the newer framework. So as I said, there's this legacy code problem, that there are just code there that nobody really knows how it works anymore. And so if you have to upgrade, and if you have to touch that code, then you have to understand it again. It takes a lot of time. You also might have code in your code base that is reused a lot of times. And so if you need to touch that code that is reused a lot of times, it's a lot of testing, right? You have to make sure that the whole application works correctly if you need to touch that piece of code. And of course, the developer experience is not that good as well, because the larger the project, the slower your IDE is going to be, the slower the build times are going to be. Even just running something on your local machine might take a lot of time to start up, might take a lot of time to re-render the page after you made some changes, and so on. So yeah, you have all kinds of problems with a large application, and the solution could be the micro-frontend. So on the back end, what happened is that people said, well, let's do microservices, and the microservices, they should deal with just one thing, and they have their own database, right? So the picture becomes a bit clearer in the back end and in terms of the database, but the front end was still, and we could say, I think that most front ends are still a monolithic front end. They combine a lot of functionality from maybe multiple microservices. And the idea is that you can break up the front end into multiple smaller pieces. Now, this is not a good idea. This has been around, but I think very recently, technology really made this possible. Okay, so I think the micro-frontends or micro-frontend is a pattern to break up a monolithic front end into independently deployable pieces. And I think it's important to note that it's not a pattern to break up something into reusable pieces. So you really just want to break up your application into multiple pieces so that you can independently deploy them. You can work on them independently, and they don't affect the other parts of the application. Okay, so we did some implementations in our team for micro-frontends, and I'm just going to kind of quickly explain how we did that. So, for example, if you have an application and you break it up into smaller different parts, like on this screen, on this slide, on the right, you have micro-frontends, you have 3 of them, and they make up the whole application, but you still have to have some kind of a thin layer, we call it a host, that bundles these applications together. So the host should have very limited functionality. It really just loads the code for the micro-frontends and does some kind of routing. because that cannot happen in the micro-frontends, but everything else happens in the Microsoft frontends, like loading data and displaying data and so on and so on. And so you can think about a micro-frontend as something that is an application, but this application has kind of a public API. And the public API, what really that is custom elements. And we're using the web component standard here. So it's a standard that browsers, modern browsers do understand. And it's a standard that multiple frameworks can agree on. And nowadays, Angular has ways to create custom elements, and React has ways to create custom elements. Vue has ways to create custom elements. So most major, frameworks, I would say, support this kind of exposing components, their own components as web components. So the rest of the application is just a regular, let's say, Angular application with all the features that Angular gives you. And what you end up with is multiple different repositories. For each repository, you have a continuous integration and delivery pipeline, and a location where you deploy your application. So if you change something in any of the micro-frontends, you only need to change the code for that particular micro-frontend, and you can deploy it independently. Okay, so the host application has a small bit of code that loads the micro-frontends, and it's fully on demand, right? So unlike maybe an Angular application that can also lazy load some of the parts, it still loads a lot of things up front. But with micro-frontends, you really load the whole application when it's needed. Okay, so what is kind of the experience with working with micro-frontends? So one thing that is very different from a monolithic application is that for a monolithic application, you have an overhead because of the complexity. So like I said, if you touch one part of the application, it can have effect on a lot of other parts of the application. And that just slows you down because you have to make sure that whatever you change has not broken the application. So with micro-frontends, there is an overhead because you need to do things many times. So you need to create a lot of repositories. You need to configure your continuous delivery pipeline a lot of times. Maybe you're using something in all the micro-frontends, and so you need to maybe copy-paste that piece of code in order to keep them independent. And so, for example, if you want to make a change in the monolithic front-end, that's maybe one place you need to change the code, but it's kind of a big bang. You don't really know what will happen to the whole application. But in the micro-frontend world, you need to change the code maybe many times. Like in this example, you need to change it 4 times, and it's the same code. So it's kind of, it's not very intuitive to do this, but it has the advantage that you can do it step by step, right? So if somebody asks, how much time is it going to take? Well, with a complex application, you can only say, well, I don't know. We'll do it, and then we'll see whether it works, and we'll do all the tests, and we'll have to go over the application and make sure every part is working. With the micro-frontends, you can say, well, okay, it's going to take 2 days for this part of the application, but I will have to do it 4 times. So in total, it's probably going to take around 8 days, right? So yeah, there is advantages and disadvantages of doing it. So one other thing that is a common question is, how do you actually develop the micro-frontends? So you start with developing a micro-frontend. You implement some kind of a functionality, and then you integrate it into the host application. And then you go back to the micro-frontend, maybe make changes, and then you check in the host application. So the way you do this is that your micro-frontend code is deployed after you make changes to maybe a development environment, and then your host application loads the micro-frontend from the development environment. So you don't have to run them both at the same time. The kind of the only situation when you need both is when you're trying to debug the interface between the host application and micro-frontend. But that should, rarely happen, because you should keep the interface, like the inputs and outputs to the micro-frontend to a minimum. Okay, so some other considerations that I want to talk about is performance. So, for example, if you have 10 different micro-frontends and you need to load all the files for the 10 different micro-frontend, there may be a lot of files. So I think the reason I think that the world is ready for micro-frontends is because we kind of pretty much have answers for all these problems. For the performance, I think we have HTTP2 or newer versions of HTTP that can bundle your network requests, and you don't have to wait for a lot of files to be loaded asynchronous, after one another with HTTP 1.1. So memory, do you have to load the same Angular framework maybe 10 times if you have 10 micro-frontends with Angular? Well, there is Webpack 5 helping you with that, and the module federation especially, and that can pretty much take the Angular framework and load it just once, and then load your code, only the parts that are different. So you have to kind of think about the boundaries of what goes into a micro-frontend, and usually this is kind of some kind of a domain or a vertical stack of dealing with one problem, and it's the best if you have very little inputs to the micro-frontends, but the micro-frontends they do everything themselves. So I'm going to show some example. So the support model for your software need to adapt, because then people have to be able to kind of understand a smaller piece of code. But that smaller piece of code is easy to understand. You don't have a complex directory structure. You don't need to think about where a component might be, because the micro-frontends, they tend to be smaller and easier to understand for somebody who haven't seen the code. But it's the best if the micro-frontends, they have owners who really know the code still. So the design, it's pretty much the only thing that you want to reuse between the micro-frontends is some kind of a design system. So your company might have a design system, or you might be using, say, Angular Material or some other design system, and you reuse that design system between the micro-frontends, but not any of the business logic, even if the business logic maybe has to be done twice into micro-frontends, because that would create dependencies between your micro-frontends, and then you're back at the kind of the problems that the monolithic code base have. Okay, so now I'm gonna try to show you some working example of the micro-frontend. Okay, so on my screen, I have an example where I have my favorite example, the list of SpaceX launches on the left. And if you click one of those, then it will load on the right. So if I click on the left, it loads on the right. And this might look like just a plain old application. However, the host application is actually pulling these two components, so the list of the launches and the kind of the right side that shows a little bit more detail about one particular launch, from a micro-frontend. So what happens is, and I'm gonna show some code here. So here I have just a very simple Angular application. It could be a React application, it could be whatever you want. What's important here is that this application has just one very simple component. I'm going to just open this one. What you see here is I have this header, and I have the main section. And in the main section, I have two components, basically. The launch list and the launch details. So the launch list component has one output. It can tell you what is the selected item. And the launch details expects one input, and it's the kind of the ID of the launch that you want to display. So the host application is very simple. It captures the output event from one component and passes it to the other component. Now, I could even do something better here, and I could, because the launch list and the launch details are coming from the same micro-frontend, I could even manage the communication between those components in the micro-frontend itself. But for the sake of showing you how the inputs and outputs work, I did it this way. Okay, so this application is basically just like that, and there should be one library that is important here, and this one library has one service, and this is a very simple service. What it does, it goes and loads the micro-frontend. So you can give it a name, the name of the micro-frontend, and it will, it's a very simple code. It will just go to a certain URL that has a certain pattern. It starts with micro-frontend, then slash, then the name, and then the files that make up that application. So this code, I created this code to kind of showcase what happens. But in a production environment, this might look a little bit different, but it's done for the debug versions of these applications. Okay, so it has just this one method that basically appends a script tag to the body of the document. And by appending the script tag for all these scripts, the browser loads these JavaScripts, and then they start to bootstrap the application, the other application that is the micro-frontend here. Okay, so this application is very simple. Like I said, it just loads the files, and it just uses the custom elements that are exposed by that micro-frontend. So the micro-frontend itself looks a little bit different. So this is an Angular application as well. What's important here is that this Angular application has a library that is called custom elements, and this library has the list and the details components, and these are just basically very simple components. They wrap the Angular components so that I can expose these components as custom elements. The way that happens is that I'm here using Angular elements. So with one of these lines, I define a custom element for the list component, and I define a custom element for the details component. So this is, if you, in your application, this is an Angular application, as I said, if in my application module, I load the custom elements module, what happens is that the custom elements module will wrap my otherwise completely plain, simple Angular components into custom elements. So if I go and look at maybe the list component, what happens here is that it has one output for the selection, right? And if I go to the other component, the details component, this is, this is code just for the custom element. It has one input. So with custom elements, you get string inputs. So this component, the Angular component that I did, accepts a number. So what I'm doing here is that I have the setter for the flight number, which is the ID of the launch. And it's a string, so I need to convert it to a number, and then kind of, and like, this way I'm actually using a subject here, so that I can, so that I can use it with an async pipe in my template with the real Angular component that accomplishes showing the details. So if I go to that one, this is the Angular component that displays the details of a launch. And you can see that this input is now a number. So I can make use of TypeScript and type safety and all the things, because this is just an Angular component. And basically, that's the reason you want to wrap this Angular component into another component that is then exposed as a custom element, so that you can do all kinds of these things that don't belong to the actual functionality of the component that is displaying the details. Okay, so so this application can be run as well. So yeah, I'm showing here, two terminals. And the left side, it has some errors, but never mind. It is running the host application on my local machine. And since I don't have a development environment where I put out these applications, on the right side, I'm running the Micro-Frontend. So I'm running two applications locally. And you can actually go and see what the Micro-Frontend looks like. So this is the Micro-Frontend application. It has this red header, so that you know that it's a Micro-Frontend. It's just a demo of the components. Like, the component here has some fixed wired-in input, and this is the list. So these are actually the same components that are being used by this other application, except that this other application is using them as custom elements, so as web components. Okay, so there is a couple of things that is worth mentioning here. So when you're doing the Micro-Frontend, there's a couple of things that you need to change. So one important thing is that I'm gonna go back here and open up the DevTools. I'm just gonna reload it. So one important thing is that when you're loading your application, if you take a look at, for example, this file that was produced by the Angular CLI when it built the application, it has a way of defining all the code on the window object in a certain module. And you need to rename this module for every Micro-Frontend, because otherwise they would go into the same module or the same kind of namespace, right? And then they will just conflict with each other. So the way you do this is that you introduce just a simple addition to the Webpack configuration. You need to override this JSON-P function that Webpack is using. So by default, if you go here, this other application, and take a look at what this application is using. By default, okay. To go there. So let's look at the same file. By default, Webpack uses this name, so Webpack JSON-P, right? If you would compile this other application and not change it, then it would use the same module name. So code from both applications would land in the same namespace or module, and that will have some very nasty side effects. So you need to change that, and the way you do that is that you just replace. Sorry, in this file, you just replace let me scroll up. You replace this thing, the builder here, with something that is called the Angular Builder's custom webpack package. So you need to install this package, and you need to replace what Angular has here, so it's its own, and you need to define the file with some additions to the webpack configuration. So you cannot do this because you want to override the webpack configuration that Angular CLI creates, and you don't want to kind of eject the configuration. So you don't want to actually deal with the configuration, with other parts of the configuration, and then you don't want to deal with the configuration when something is changing in the project, or when you're upgrading to a newer Angular or whatever. So you want to let Angular handle the webpack configuration because that's the kind of the easy way. But you want to have this one addition, and this one addition, looks just like this. Okay, so that's one important thing that you want to do, and then the other thing that you might want to do, but that's just a small thing, is that you want to have the base href here somehow embedded in your Angular JSON configuration, so that when you start this application, it's going to be available on this URL. By the way, you also want to change the port. So in this case, I'm not using the 4200 port, but I'm using 4300. And so in the other application, so on the other side of things, what you want to do is for local development, right? But not just for local development. If you're using a development environment to host your Micro-Frontends, you want to create this proxy configuration. And a proxy configuration basically takes the path where your Micro-Frontend is deployed and redirects it to a different port. Like in my case, it's a 4300. Because the files that you want to load from this path, they are hosted by this other locally running application. Okay, so but if you have a development environment, you could use a different host name and load the Micro-Frontend from there, and you don't even have to host it locally. And with that, you can achieve a way of working where you only work with one code base. So it's either the host application or one of the Micro-Frontends that you're working with. And like I said, since the Micro-Frontend has its own page with its own kind of showcase or demo of the components, you can work with these components right here. And once you want to integrate them to the host application, that's where you start using it from the development environment where you already published it. Okay, so yeah, I think that's all I wanted to share. So now back to Norbert and see if we have some questions.
Thanks, Balazs, for the awesome presentation. It was great to see this whole thing in action and not just see or read some blog posts about how great it might be. We do have some questions for you, but before we get to that, you can still sign up for the raffle. Afterwards, I will close down the form and to announce the winners. Balazs, do you need help with? I mean, I can help you with the questions. So Alex asked, what tools do you use? Oh, awesome. Oh, wow, we have technology here. I didn't know that it has this feature. So you guys see the
very nice
question on the screen as well. Thank you, Natalia.
So but I'm going to read it out loud. So what tools do you use to set up a micro-frontend ready repository? So it's actually just, you can accomplish these things with just a plain old Angular CLI. Like I said, what's important on one side is that you configure the output of Webpack so that it doesn't use the default. So your micro-frontends don't interfere with each other. And on the other hand, in the host application, you just need to configure the proxy. So when you want to load your micro-frontend, it loads it from a different URL. And whether it's local or whether it's your dev environment, you need to load it from somewhere else. Now, with that said, I'm actually using the NX tools to create my repositories, because I find that that NX is a good addition to any Angular CLI toolset. But I don't really, because in the NX toolset, it can work with monorepos where you have lots of applications, and lots of applications are reusing certain libraries. So I don't really use that functionality here. And when you're doing micro-frontends, you don't really use that functionality. But yeah, it's still a nice addition, and it has a nice feature, a couple of nice features, but not related to the micro-frontend way. So there is, I think, or I've seen somewhere, I don't quite remember where, I've seen some tools that you can use to make it easier to create the micro-frontends. But right now, I don't think that there is kind of a definite go-to kind of package that you can just download and make everything or configure everything the easy way. Yeah, and also, so if you're doing this in production, you might want to do a couple of other things, right? Maybe you want to just have one JavaScript file per micro-frontend. So you want to bundle the JavaScript files into one, and so some other things. But yeah, we do them by hand, unfortunately. But I'm hopeful that in the future there will be some great tools to do that. Okay.
Thanks. Well, we still have some questions for you, so we can move on to the next question from Benoit.
Okay. So the question is, when not to use micro-frontends? Right. So I think, when the application is just a simple application. So when it's maybe, a couple of screens and not a complex application, you definitely don't want to use micro-frontends. So I think it's the same thing with microservices. You start with one application. You could name it a monolithic application, whatever. But, when you have a small application with a small code base, you want to have just one application because it makes life easier. But the advantages of micro-frontends come when you have a large code base, and when you start to have a large code base that is larger than what one team can actually understand and maintain. So that's where you can start thinking about breaking it up into micro-frontends or multiple parts that are integrated together into one application. And these smaller parts, they are now independent, and they can be developed by a smaller team. And the smaller teams kind of just put together what they have into one large application. But what's important here is that the smaller teams, they don't have to kind of agree on day-to-day problems with each other, right? They have their own code base, and whatever they do, it's not affecting the other parts of the application. So that is, kind of the advantage of micro-frontends. But like I said, if your project or if your application is not complex enough, that you don't need to use micro-frontends.
Okay. Our next question is from Balazs.
Okay, so do you think it's a good idea to use iframes to load the micro-frontends? So I think iframes have been around for some time, and so using web components is I think is better in a number of ways. So when you have an iframe, what you really are doing is when you're creating the iframe and loading the micro-frontend or loading any code into the iframe, it kind of loads the code and it bootstraps the whole application. In terms of user experience, that's not ideal at all, because when you're switching between micro-frontends that are maybe on different pages in your application, every time you open up a new iframe and load the application, that small part of the application into the iframe, it needs to bootstrap, and there's a slight delay. So with using web components, you need to load them once, and they stay in the memory though. So when you go to a different page and then you come back, it's lightning fast. The component, the custom elements are defined, and the browser just understands them. So once they have been loaded, you can go back and enforce. And also, what you can do is you can have an Angular application with maybe services that load some data from the backend, and those services stay alive when you go to a different page, and when you come back to the page where you're using the micro-frontend, the data is still there. So it's in the browser's memory. So it makes it much more fluent and makes the user experience much better. And also with custom elements, you can actually have inputs and outputs that work just, like from Angular, you can use them as kind of simple inputs and outputs to a component that would otherwise, could be an Angular component, but it's just a custom element, but still has the inputs, outputs. So iframes, they don't really, there is like, you can have some forms of inputs and you can achieve some kind of an output from the iframe, but it's not really convenient. So yeah, I think that, there's a couple of reasons why web components are much better.
We have a question from Hugh as well.
Okay, so the question is about how do you I would say, how do you reuse functionality between your micro-frontends? So let's say, let's try to find an example. You might have some kind of an error handling on your backend calls, right? And so it's always the same, right? You go to the backend, and if there's an error, you want to log it somewhere, or you want to display the error message to the user or whatever. And you have 10 different micro-frontends, and you don't want to implement the error handling 10 times. So the bad news is, if you do use one common library in all your micro-frontends, then you then you start losing the advantage of the micro-frontends, because if you have one library and you're using it 10 different times, then it introduces a dependency between your micro-frontends, and they're no longer independent. They're no longer independently deployable. Or better said, you can create a library, but then you start to have to deal with the complexities of creating a library. Because it can be an npm package, right? So an npm package, but then you start to have different versions of this npm package, and you need to upgrade all of your micro-frontends to the latest version of the library. And so yeah, you can do that, but I think it's a lot of overhead. And so the thing is that doing something in a library is introducing communication overhead between the teams. So it's, in my experience, like what I always think about is that I work in a company where we have a lot of front-end teams, and every front-end team, they tend to implement their own wrapper around the HTTP client in Angular, for example. And they, for some reason, right, they don't want to agree on one commonly used version of it, because changing anything in that common version will become kind of an impossible task if a lot of projects are using it. So yeah, I think it's just you have to be very careful with these things. And although it seems like it seems like a bad idea to just copy and paste the code maybe, or to let the team implement their own version, in terms of autonomy of the team, and in terms of might sound counterintuitive, but in terms of speed, the team can work faster if they fully own their own code base. Yeah, so I hope that kind of answers the question. But yeah, I would say try to use npm packages that are publicly available and that are owned by somebody, and try to use packages that have they are very popular, or is like a huge number of downloads per week or something like that. Those libraries, they tend to be stable, and they tend to be supported by a team or by a couple of persons, and just use that and try to find something that suits your needs, instead of trying to develop your in-house libraries that you reuse. So yeah, I mean, like it's like I said, with micro-frontends, you have overhead by repetition. So you just need to do the same thing many times.
You got some tough questions, Balazs, to answer. Last question from Christian. I think I can answer that one. So what is written on my awesome shirt? I'll try to fit it in the camera, but I'll also do a translation. So roughly, I would translate it this way, that I envy Santa because he only needs to go among people once a year. So that's the answer for that question.
Okay.
Thanks, Balazs, for all the answers and sharing your experience. I think it's really a great topic, and a topic that we will be dealing more and more in the coming years as frontend just keeps getting more and more complex. And now, stick around, we'll get a recap at the end of the whole thing, but now it's my turn. I will share my screen, if I find the appropriate screen. Yes. Okay, so hopefully you see a bunch of names. I'm not going to use these emails or names. I will delete them. These are the people who signed up for the raffle, and now I do my job. So I'm using random.org to generate a number. Let's see our first winner. And our winner is number 2. So Bence, congratulations, you won one of the licenses. Let's see our second number, and that is number 9, and that is Attila. You won the second license, so I'll send you the details to the mail that you provided, and then how you can redeem it, and then have fun with your new toy. And let's have everyone together before we say our goodbyes. Okay, so Stefan, you're back. Everyone's here. Natalia, can we have you here as well, maybe?
But just for a second, because I'm very shy.
Thanks. So as you saw, the magic was happening throughout the whole event. That was thanks to Natalia. Thanks again for doing this and reaching out to us for doing this. Without a doubt that this was the most professional online event we had so far.
Thank you.
There's no words I can use to express our gratitude to you.
Well, thank you very much for this lovely shout out. Thank you for our wonderful speakers. Thank you to the audience, and hopefully see you next time.
Yeah, you too. Balazs, Stefan, thank you also for doing these great talks. I think there's a lot that to take away. I guess, Stefan, you use your own domain to share your slides, right? So you can find those. Balazs, will you share your slides and the code that you used?
Yeah, definitely. I can. I'll send you the. Well, I'll put it out somewhere on GitHub.
Thanks. Then we'll keep in touch and I'll make sure that that's available because it also contains a lot of goodies. So again, thank you all. Next year we will continue with BudapestJS. Hopefully we also have the opportunity to do it in person, but regardless, most likely we will do live streams from now on as well, or at least give it a shot and see how that works. So thanks again for everyone and happy holidays to you.
Happy holidays.
Bye-bye.